Good morning, students. Can you hear me? Can you see the screen?
Yes, sir.
Yes, sir.
All right, beautiful. All right, so a lot of persons not here, but we're gonna start. But we did say we're gonna start at 11, and the notice was given. All right, so we're gonna start out by going through this question that I gave you in the class. All right, that's how we're gonna start out. Go through it and explain it. Everybody would have gotten it right before they left the classroom. All right, and then we're going to look at some past papers just to get some additional practice and for you to see the level of difficulty and the tendency with which the questions are written. All right, so you can get a feel of the questions. All right, so let me just start right away. All right, so this was the quadratics question. Give us this quadratic function right here. And we were told to write it in this form, which really is to complete the square. It said A, H, and K are real numbers. That's what this means. They are real numbers. And here we are told to state the value for A, H, and K. I did not focus on that in the class, but that's fine. I was more interested in persons getting the expression correct. All right. So remember that because CSEC tend to change the way they represent this all the time, what we use is a standard way or a unique way that allows us to rid ourselves of any ambiguity. We understand everything that we're writing. So instead of using this form, we are going to use A into x minus xt squared plus yt, where t means turning point. And so xt is the x value at the turning point, yt is the y value at the turning point. But it's really the same format. These are really the same. It's another way of writing it. All right. So let's go. So they give us g of x equals 3x squared minus 8x plus 2. And we are going to complete the square. So we're going to write it in the form g of x equals a into x minus xt squared plus yt. Remember, the method that we are using is that even though they give us a plus right here, we are starting out with a minus, x minus xt, because the formula that we are using for xt will keep it consistent with having a negative here. All right. So how do we get the xt value to go here? The a value, we get it from the standard form, but how do we get xt? It's a formula for the xt that you must know, which is that the xt value is going to be negative b divided by 2a. Where do we get a and the b from? We get it from the standard form. So I'm going to put those values in red. And from here, the a in the standard form is a coefficient of the x squared. X squared is that term. The number in front of x squared is a 3. So it means that a equals 3. The b is a coefficient of the x. The number in front of the x is the b. So this is the number in front of the x. You have to realize it that it is a negative 8, not just a 8. You have to see the sign in front of the number. So the b is negative 8, not 8, negative 8. So the b is negative 8. And then the c is a constant term with the sign in front of it. This case, mute your mic, please, mute your mic. The c is a positive 2 in this case. So c equals 2. So those are the values that we're going to be using to calculate our xt and our yt. Right now, we're working on the xt first. And this is a formula that you must know if you're going to use this method. There are other ways to complete the square, but this is the method we're using in this class and this program. When I teach add maths and pair maths, I will use another method. All right, but this is the method that is useful at this stage. All right, so the xt is equal to, you have to be careful with these negative signs. Once you're doing math and you come up with a negative sign, you have to be super careful with the negatives, because most mistakes in math at this level are made with the negative sign. All right, so I want to put down this minus here first. Put down that minus that must be there first. And then the b itself is -8. The b itself is -8, not just a 8. The b itself is -8. So I'm going to write the -8 for the b. So it's a minus minus. I can put a bracket around it, or I can leave it as is. Minus minus. It doesn't really matter. It becomes a plus anyway. And then we're going to divide this now by 2 times a. And the a value is this 3 right here. All right. So I'm going to put the 3. This minus minus 8 gives us a positive 8. And we're dividing this by 6. And at CSEC level, you're always expected to simplify your expressions to lowest terms. This can be simplified because we can divide this by 2, and we also can divide this by 2. We can divide it by 2. If we divide this by 2, it becomes 4. And if we divide this by 2, it becomes 3. So xt is equal to 4/3. What it means then is that this value is going to come and replace the xt right here in that expression. That's where it's going to go when we write the final thing. So now that we have the xt, we really now need to calculate the yt. And then there's a formula for yt that you must know as well. So the yt formula is 4ac minus b squared divided by 4a. That's a formula for yt that you must know. All right. Again, the a, the b, and the c, they come from standard form up here. So we'll put in the values carefully. All right. So let's go. So it's 4 times the a. The a value right here, as I said, is a 3. So it's 4 times 3 times the c, where the c is at 2. So the c is at 2 minus, this minus is this one. And then we're going to be squaring the b. Remember now that the b itself is -8. So we're going to put down the -8 for the b, and then we'll put the square on it. And we're going to divide all of that by 4 times a. 4 times a. And again, the a is equal to 3 up there. All right, so put in the 3 right here. Now the key thing right here is that a lot of persons make mistake right there because of the negatives again. You have to be careful with the negatives. What we must realize, mute your mic, please. You have a question? If you don't have a question, mute your mic, please. Keep your mic muted unless you're saying something to me. Somebody saying something to me? If you don't mute your mic, I'm going to put you out of the class. You cannot have a class with persons speaking in the background. You have to keep your mics muted. Okay? All right. So I was saying a lot of persons make mistakes right here because of the negatives again. All right? So let's talk about it a bit. So this negative right here, it is not under the square root sign, you know. No, it is not being acted on by that square, not the square sign, you know, the square, you know. It is not being squared. There's nothing affecting it really. So it stays as a minus. The minus inside here beside the b is under the square. So you're really squaring this -8. And if you square -8, it will become a positive number. because negative 8 squared really means negative 8 multiplied by negative 8. So it's going to become a positive 64. This is going to become a positive 64. But this minus is not changed because it is not squaring. Some persons change it to a plus. No, it's not squaring. It will always remain a minus because it's not squaring. Whether the b is positive or negative, this minus will stay a minus because it is not squaring. This expression is that the square is only on the b. The square is not on the minus. It's squaring only the b. If they wanted to square the minus, they would write it like this. All right, so let's focus on that. That's where a lot of persons made mistakes with this question right there. So let's correct that one time. So the yt, they're going to work this out now. The yt, therefore, is equal to, this is 4 times 3 is 12, and then 12 times 2 is 24. That is 24. This minus remains a minus. It is not squaring. This negative 8 squared becomes a 64, a positive 64. So I'm just going to write 64 there. And dividing that by 4/3, which is 12. Then this becomes 24 minus 64. So you're subtracting a large number from a small number. It must become negative. 24 minus 64 is negative 40. So some persons have the negative 40 and then throw away the minus. You cannot throw away the minus. So this becomes negative 40 divided by the same 12. Again, this is a multiple of 4 and this is a multiple of 4. So it can be simplified. Once your expression can be simplified, you are expected to simplify it. So we divide the numerator by 4 and we divide the denominator by 4. When you divide this numerator by 4, it becomes negative 10. Notice I brought back the negative. Some persons throw the negative away. It's like you have a dislike for negatives. You have to have an eye for the negative sign because that is where most people make mistakes. You have to have what we call negative antennas, looking out for them. Be careful with them. Double check them. Anything you do with the negative until you master it and you become perfect at it, you always show extra care with the negative sign because that is where a lot of persons make mistakes. People tend to just ignore the negative sign. No, you cannot ignore it. It changes a value. 2 and negative 2 are two different things. So if you have a negative 2, you cannot just make the negative disappear. 2 and negative 2, they mean different things. They're not the same. Mathematics is the most exact science. So you cannot throw away the negative. All right. So this is negative 10 when I divide this by 4. And if I divide this by 4, it becomes a 3. And this cannot be simplified any further. So that negative 10 over 3. So it's like we're saying this really is like it is the plus yt that is equal to the minus 10 over 3. So the plus yt up here, I'm going to replace it with minus 10 over 3. You just that I don't need to show the plus on the yt there. If I put yt by itself, it is really plus yt. All right, so that plus yt, I'm going to replace it with negative 10 over 3. It is equal to negative 10 over 3. So now that I know my a, my xt, and my yt, I can now write the expression in the vertex form when we complete the square. All right, I'm taking my time with this solution. Anybody don't understand something, let me know. All right, so I'm now going to write it. Let me just use a different color. So I'm going to write the expression now and put in the values because I'm completed the process. So the g of x is going to become, the a is 3. See there, the a is 3. So they put the 3. Bracket x minus, see, x minus. And then xt now is 4 over 3. So I'm putting 4 over 3 for the xt. Don't forget the square. We're forming the perfect square, so you cannot forget the square. So you have to ensure that you put down the square. And then as we said, the plus yt is negative 10 over 3. So I can just write it like this, minus 10 over 3. I don't have to put plus minus 10 over 3 because plus minus is the same as minus, right? So this becomes just minus 10 over 3. And that is it. I've written it in this format that they asked me to do it over here. But this question asked us to state the value for A, H, and K. Let me show you the comparison now. So this is what we got. This is our answer now. But further, they want us to state the value for A, H, and K. So let me write out about what they asked us to do. They asked us to do A into X plus H squared plus K. That's what they asked us to do. So it's like we are comparing the values to get the A, the H, and the K. So if you look right here, it is clear that the A is equal to 3. The A is equal to 3 right there. Nice and easy, obvious. So the A is equal to 3. Now watch this now. The plus H is equal to minus 4 over 3. Where they gave us a plus H, we have a minus 4 over 3. You cannot ignore the sign, the negative there. So the plus H, where they gave us a plus H, we're ending up with a minus 4 over 3. It means then that plus H is equal to minus 4 over 3. But generally speaking, we don't write an expression with the plus in front of it if it's a positive number, a positive value. So therefore, we can remove the plus. And so the H is just minus 4 over 3. All right? And then now, we also want to state the value of the K, and it's a similar situation. The plus K is minus 4 over 3. Where they gave us a plus K, we are ending up with a minus 4 over 3. So it means that, again, the plus K is minus 10 over 3. But again, we don't need to show this plus. All right? So it means that the K is just minus 4 over 3. But after a while, we'll practice these things a lot. You won't need to write the plus first, as I did here and here. You will just know that the H is minus 4 over 3 and the K is minus 10 over 3. All right, so we have completed the first part. Anybody have any questions so far there? Anybody? Somebody answer, let me know that you're seeing, you're hearing everything all right. Somebody answer.
No, sir. No, sir.
All right, good. Now remember, I know at any step I go and I say something or do something that you don't understand, you need to let me know right away. Because sometimes if you don't understand something in the middle, then you have a problem getting to the end. If you don't understand something at the start, you have a problem getting to the end, because it's like your mind is just stuck on that thing that you don't understand. You maybe not even hear anything else that I say. So as I put something on the board or on the screen that you don't understand, just say it right away. Sir, I don't understand that. Explain that so that we can go forward. All right? Don't have your mind lagging on something that you don't understand. All right. So we'll finish the first part. So we'll come to the second part now, right here, which is asking us to state whether the function g of x has a maximum or a minimum value. So we know that quadratic functions, they have a maximum or a minimum value. What tells us whether it has a maximum or minimum value right now at this level is the a value, the value of the a. Or we can say the square term. When the square term is positive, as it is in this case, because the a is positive, we know that the quadratic function will have a smile shape. When it has a smile shape, it means that the graph comes down to a minimum point and then it goes back up. So when the a is positive, automatically the quadratic graph will have a minimum value because it will have a minimum point. So it's quite easy. This one is quite easy because the a is positive, the a is 3. It means that we actually have a minimum value. As simple as that. We have explained it in the class multiple times. All right. If anybody don't understand, let me know. Because the a is positive, it has a minimum value. One day, I'll go a little bit further so that you can really appreciate and understand the mathematics aspect, apart from just the graph aspect of it. Right now, I'm explaining it from the perspective of the graph, because we did do graphs in the class, plot points and do graphs in the class, where we show that when the A is positive and we plot the points on the graph, we get a graph that has a smile shape. And when the A was negative and we plotted points to get the graph, we got a frown shape. So right now it's like a no thing. But there's also a way to explain it from this, the mathematics around that. But I'm not going to do it just yet. When we understand this and appreciate it, then I'll explain the minimum and the maximum from the perspective of this format, that expression. All right, I'll do that at some later stage. I don't want to tell you too many things right now. All right, so just know that once the A is positive, it has a minimum. So let's answer it that way. That's good enough for now. So let's just write this. So part 2, it says state whether it has a maximum or a minimum value. So we're going to say since the A, which is equal to 3, is positive. This is a symbolic way to write positive. P plus VE, positive. Instead of writing out the word, we have to understand that mathematics is a subject of symbols. All right, mathematics is a subject of symbols. So we use a lot of symbols. So this is like a symbol of positive. All right, it is accepted. So since the A is positive, we can say G of X, function G of X, has a minimum, mute the mic please, value. Simple as that for now. It has a minimum value. So the maximum that they talk about here is irrelevant, and the maximum that they talk about here is irrelevant, and the maximum that they talk about here is not irrelevant. We know that going forward, it is a minimum that we have. The reason why they keep asking, for example, here, they say state this maximum or minimum value. It is because they don't want to tell you what the answer for this part is. And the same thing for here. They say state the value of X power G of X is maximum or minimum. Again, it is minimum, but they don't want to tell you the answer for this part. All right, but we now know that it is minimum because the A is positive. All right, so we are saying it has a positive, it has a minimum value. So that is the answer for here. Answer for this one is minimum. It has a minimum value. That's part 2. But good so far with that and the explanation why it has a minimum. But okay?
Yes, sir.
All right.
Yes, sir.
Good. Let's go to part 3 now. So part 3 is asking us now to state the minimum value. Remember, when we say it's not maximum, we now know that it is minimum. They want us to state the minimum value. And the minimum value of G of X, remember, it is the lowest Y value on the graph. Remember, we said the graph is going to come down to that minimum point, that turning point. That's what the T stands for. And the coordinates of that turning point is XT, YT. That's coordinates what we're using. The T simply means turning point. So the XT is the X value at the turning point. The YT is the Y value at the turning point. The YT value is a G of X value. It is also a function value. So if they ask for the minimum value of the function, they're talking about the Y value. If you ask for the minimum value of G of X, they're talking about the Y value. It is like the Y values and the G of X values are your output values from the function. So how the function works, for example, this function up here, how it works, is that you put X values in here. And this formula, this expression works itself out and tell you what the function value is. So the output values are the function.
Is the
Mute your mic, please. Right? So the output values are your function values. Your Y values are your function values. So if the question says, what is the minimum value of the function? It is asking for the lowest Y value. So let's talk about this, why this is a minimum again, and why it is the Y value that they're talking about. Let's just say it one more time. When we're doing the other past paper question, I'm not going to explain it this much again, I'm just going to do the question. I'm just doing this as a final revision for this topic, but I'm moving on to something new tomorrow. All right. So remember, if your graph has a smile shape like this, you should always take the sense of a graph as if you're going from left to right. As if you're going from left to right along the graph. And you're looking to see as you go from left to right, how your Y values are changing. What does that mean to your Y values? Because your Y values are your function values. So as you go from left to right, because as you go from left to right along the graph, what does that mean is that it's like you're constantly increasing your X value as you go from left to right. So you want to see what does that mean to your Y values as your X values increase. Because if you go from left to right, your X value will always be increasing. And you want to see what is that mean to your Y values as your X values increase. Your X values will increase once you are going from left to right. So we always take the sense of a graph as if we are going from left to right, and then we're looking to see how our Y values are changing. All right. So if our graph has a smile shape, which we said it did, because the A is positive, it has a smile shape, and therefore it has a minimum value, a minimum turning point. It has a minimum point with a minimum value. If you look from left to right as you go along the graph, this way, from left to right, your Y values are coming down because the graph is going downwards initially. So your Y values are decreasing initially as you go from left to right. When you get to this point, it decides not to decrease anymore. And then as you pass through this point, your Y values starts increasing again. Your Y values start increasing again. They start to increase. So over here, your Y values are decreasing. Over here, your Y values are increasing. So it means that your Y values would have gotten to its lowest value that it is right there. Because they will increase forever and ever, amen, over there. They will increase again forever. They will never come back down. Right? So they decrease initially to this minimum value, and then they start to increase again over here. So therefore, this Y value becomes the lowest Y value on the function when it has a smile shape. And that value is called the minimum value of the function. So when the question asks you for the minimum value of the function, the minimum value of Y, or they say the minimum value of G of X, they are talking about this value, the Y value at the turning point. That is the lowest value on the graph when it has a smile shape. If it was a graph with an A negative with a frown shape, then that would be a maximum point, and it's the same XT, YT, and this would be your maximum value, the YT, maximum value, if it was a frown shape graph. Instead of being a minimum, it would now be a maximum. So the minimum or maximum value is referring to the Y value at that maximum or minimum point. Just that for this question, it is a minimum point that we have. And we need to understand that. X don't have no maximum or no minimum. X don't have a maximum value or a minimum value, right? Remember, you know, X can go from negative infinity over here all the way over to positive infinity, your X values on the graph. All that will happen is that your graph, if you go further, will continue up like this and go all the way up that way, and on this side we'll go all the way up that way, all the way up here, up to the sky for values of X. So X can go from negative infinity to positive infinity. X don't have no maximum or no minimum. You can put any X value you like in this graph, in this function. Any X value you can put in that function. Any X value you like, you can put in there. X don't have no limit. There's no limit on the X value for these questions. I'll explain that sometimes they limit it purposely, but generally speaking, you don't have any limit on X. So X don't have no minimum or no maximum. All right, but the graph is such that it comes down to a minimum. The Y values now come down to a minimum Y value, and then it goes back up when the A is positive. All right, so the maximum minimum value is referring to the Y value. So the simple answer is that the simple answer for this question here now, to state that maximum or minimum value, it is the YT value. Simple as that. the value at the turning point, the y value at the turning point is your minimum value. That's why I said state it, but there's no need to calculate anything, just state it. I'm just explaining it out here so you can understand it. So it's a matter of just stating it, just write it down, but let's write it like a sentence. So we can say in part 3, the minimum, this means minimum, the minimum value of g of x is the yt value, the y value at turning point, which happens to be negative 10 over 3. That is it. All right, that is the value, the minimum value. And then the next part now, so far so good, everybody good with that? Everybody okay?
Yes, sir.
Good. And then the next part now is asking us to state the value of x. It's asking us for a value of x now. See? State the value of x. So this question is asking us for a value of x. So we cannot give a y value if it's asking us for a value of x. State the value of x at which g of x is minimum. In other words, what is the value of x when the g of x is minimum? It is the same x value at the turning point. That is the x value at the turning point. So again, if I were to sketch it again, right at this turning point, it is a point when the y value is minimum, the x value is the same x value at the point. So this question is asking us for this x value right here. X value at turning point. And we can see it in the function. We can see it in the function as well, right here. Right? If this x value becomes 4 over 3, which is now equal to the xt value, then this 4 over 3 minus 4 over 3 is going to cause this to become 0. And that is when the g of x is now equal to the minus 10 over 3. So that proves it. The g of x is minimum, which is minus 10 over 3, when the x value becomes equal to the xt value. Right? The mathematics show that, the formula shows that, and the expression shows that, but it's shown also on the graph. This is the minimum value. And you get this minimum value at the point where the x value is xt. So again, this is an answer where you cannot state. There's no need to work out anything. That's why it says state. It's state. There's no need to work out anything. So the function is minimum when the xt value, when the x value is equal to the x value at the turning point. Like the xt value and the yt value go together. They go together because they are the same point. Right? So for part 4, we can say something like g of x is minimum. It is minimum when is it minimum? When the x is equal to the xt value. What is that xt value? It is 4 over 3. That is the xt value. X by the turning point. Because they are at the same point. But understand that? But understand that?
Yes.
Yes, sir.
Yes, sir.
All right. And then now, the last part now wants us to sketch a graph down here. They make a sketch. Not every question in CSEC you're going to ask you for a sketch. Some do, some don't. Right? These are the typical things that they ask you right here. These first 4 things are the typical things that they ask you when they give you a quadratic question to complete the square. Those are the things that they mainly ask you. And sometimes they ask you for the axis of symmetry. Those are the things that they normally ask you, but sometimes they go on and ask you for a sketch, as I did here. Sometimes they ask you for a sketch. And here, you know, they are listing the things that they must put on the sketch. But even if they did not list these things for you to put on the sketch, you must know that these are the critical things that you must put on the sketch. You must put the critical things. What are the critical things? The critical things are the y-axis intercept, where the graph crosses the y-axis. The turning point. You want the location and the coordinates of the turning point. They want the axis of symmetry in this one, and then they want us to state the position only. They just want us to tell them the position. They don't want us to get the roots value. They just want to show the position of the roots. And the roots are the points where the graph intersects the x-axis. All right, so they want us to do a sketch. So let's go and look at doing a sketch now. All right, let's talk about the sketch again one more time. One last time, slowly. Let's do it again, one last time. What do we consider for the sketch? All right, so to do the sketch, we need some information. It's just a sketch, so we're not looking for accuracy. We just need to show the shape of the graph and the critical information in terms of where it turns and where it intersects the y-axis and so on. All right, so the standard form, which is g of x equals 3x squared minus 8x plus 2. Because this a is positive, we know that it's going to have a smile shape. Because the a, which is equal to 3, is a positive value. We're going to have a smile shape graph. The graph is going to smile. When it smiles, it has a minimum value. So it's going to smile and have a minimum point. But the standard form don't tell us the minimum point, you know. It only tells us that we only know that it has a minimum point because we know that it smiles. It is the vertex form that tells us that where the point is. The xt and the yt tells us this. So we're not going to write the coordinates for this yet until we show the vertex form. In addition to that, the c right here is the y-axis intercept. That's another piece of information we're getting out of the standard form. So the a tells us the shape, and the c now tells us where it crosses the y-axis. So since the c value is equal to 2, then our y-intercept, the y-intercept, this means intercept, is the point 0c, which then is the point 0,2. So those are the things that we know from the standard form. This, that it smiles and have that shape, and also the y-axis intercept. That's all the standard form can tell us right now. It is not able to tell us exactly where that minimum point is. We need xt and yt to know where that point is. That is why we complete the square and write the vertex form. The vertex form helps us to know where the turning point is. So we're going to look now at the vertex form. So when we did the vertex form, which is g of x equals, what is it? 3 into x minus 4 over 3 squared plus minus 10 over 3. Out of this vertex form, our minimum point, it tells us the minimum point. The coordinates of the minimum point will be xt, yt, because that's the minimum turning point, which is equal to the xt is 4 over 3. That's what we got from up here. Not negative 4 over 3, no, 4 over 3. Right here. Xt is 4 over 3. X value at the turning point. It's 4 over 3. And the yt was negative 10 over 3. So this is the xt and this is the yt. So I said that's how we're getting those. We can get these values from the vertex form. So we know where the minimum point is. And because we now know where the minimum point is, and we know where it crosses the y-axis, and we know the shape of it, we can do a sketch of it. Put those things together. Put those things that have ticked together and get the shape. And everything must be consistent. What we have mathematically here, in mathematical expressions and numbers and values, must be consistent with what we are showing on the graph. Everything must be in sync and consistent. So we cannot have for example, we cannot say that it's going to cross the y-axis at 2, 0, 2, and then put it on the lower side of the y-axis where y values are negative. Now we have to put the graph to turn where this point would be, in the quadrant where that point would be, in the correct quadrant where that point would be. All right, so let's look at the sketch now. Okay, maybe we'll put the sketch over here. Let's put the sketch over on this side. So keep those values there. Let's put the sketch over this side. So I'm going to put in a y-axis and an x-axis. We're not coming back to this tomorrow, guys. Remember, we're finishing with this today. And we're going to a new topic starting tomorrow. So those who are not here will have to watch the video. All right. So we know that the graph is going to have a smile shape from up here. All right. So we know it's going to have a smile shape. But we can't just draw any smile, you know. There are 4 places we can turn. Here, 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 or here. We have to make sure that it turns at the right place. But we know it's going to have a smile shape. It's a matter of where will it turn. That's what we want to indicate. Where will it turn? It has a smile shape. Next question is, where will it turn? Here we know it's going to have a smile shape. This now is where it's going to turn. Question is, where would this point be? This point is in a quadrant where the x value is positive and the y value is negative. Now look now, over here, we'll have a positive x. Let's mark them out. We'll have a positive x and a negative y. Up here, we'll have a positive x and a positive y. Over here, we'll have a negative x and a positive y. And down here, we'll have a negative x and a negative y. That's how the coordinates work. All right? That's how the coordinates work. Positive x go this way. Negative x is over here. Positive y is up here. Negative y is down here. All right, let me clear this up again. So basically, we're looking for the quadrant right now that has a positive x and a negative y. That is clearly in this quadrant down here. So positive x value, negative y value. So when we draw the smile, we have to ensure that it turns somewhere down here. Remember, it's just a sketch we're doing, you know. So it's not like we're placing precisely where the points are. It's just a sketch. We just need to ensure that it smiles and to ensure that it turns in the right quadrant. The quadrant now that has a positive x and a negative y. So when we draw the smile, the turn has to be somewhere down here. That's where it has to turn. Can't turn up here, so wrong. Can't turn up here, so wrong. Can't turn down here, so wrong. The turning point has to be somewhere over here, which has a positive x and a negative y. That's what we have at the turning point. All right? So that's why it must turn somewhere down here. So we know that already. The turn on the graph must be somewhere down here. The next thing now is, where does it cut the y-axis? It cut the y-axis at this point. This is the y-axis intercept. 0, 2. So remember now, y values are positive on the y-axis up here. Positive y values. Positive y values. But y values are negative down here. Negative y values. We want the graph to cross the y-axis where the y value is a positive 2. Positive 2 must be somewhere up here. So therefore, to conclude, we need a smile. We need a smile that turns down here and cross somewhere up here. Our smile must turn down here and cross somewhere up there. We just need to draw that now, because it has a turning point in this quadrant where the x value is positive and the y value is negative down here. And then it has a y-axis intercept with a positive y value. So it must cross somewhere up there, and the graph must smile. So all we need to do is draw that. Draw something that is consistent with that. Smile down here, turns down here, I should say. It smiles, turns down here, and crosses up here. Easy thing to do. So I'm going to do it now. See there? As easy as this. See? It crosses up here and it turns down here. And it's just a sketch. So having done that sketch now, which is consistent with what I have, I just now need to label it up. So I'm going to label it up now. Let's label it up in red. This very lowest point down here is my minimum turning point xt, yt. I'm just going to put the values in there. 4/3, -10/3. That's my turning point. It's a minimum point, the lowest point on the graph. And this point where my graph intersects the y-axis, where it is on the y-axis, not up here, so not down here. So I'm talking specifically on the y-axis, where the graph intersects the y-axis. That point is 0, 2. It means that the y value at this point is 2. That's the y-axis intercept that we got from the c value. Why is that so? Because on the y-axis, the x value is equal to 0. And if you put 0 here and 0 here for the x, then the g of x is going to work out to be 2. Because these two will be eliminated with the 0. So that is why the point is 0, 2 on the y-axis. All right? And that is it. That's the graph. I've placed the two things that I wanted, the minimum point and the y-axis intersect. And the shape is a smile, as you can see. The question went on to ask us to show the axis of symmetry. Let's put that in purple. Axis of symmetry. Let me move this out the way this. The axis of symmetry, wow, or the line of symmetry. What did I do? Right here. Sorry, my mistake, guys. My mistake. All right. So my axis of symmetry or my line of symmetry, let me leave it with the graph. This is our x-axis, that's our y-axis. The line of symmetry or the axis of symmetry is a vertical line that passes through the vertex point or the minimum point, like this. And what it does, it divides this graph into half and half, such that one half is the mirror image of the other half in that line. A parabolic graph, a quadratic graph, has a parabolic shape. This half and this half are equal distances from this line, that line of symmetry. Just like the graph is a sketch, it might not look that way, but if you put it on a graph, it will be perfectly symmetrical about this line. That line is a line of symmetry or the axis of symmetry. The equation of that line, that vertical line, is x equals whatever the x value is down here, which is 4/3. Because it passes the y-axis at 4/3, the x-axis, sorry, as 4/3. So everywhere on this vertical line, the x value will be 4/3. That's why it is the equation, x equals 4/3. It is vertical like the y-axis, where the y-axis has an equation, x equals 0. So any line that is vertical like the y-axis will have a similar equation, x equals a number. Where the coordinate geometry will appreciate this equation a little bit more. But for now, that is it. This is the equation of the axis of symmetry. And that is a sketch. And that ends the question. Okay? Or they wanted us to show the roots, the position of the roots. So we'll show the axis of symmetry. That line that we just drew a while ago is the axis of symmetry. This vertical line is the axis of symmetry. And I wanted us to show the position of the roots. The roots are the points of the graph intersect the x-axis. So we're talking about this point and this point. This one we can call this root 1. We can call this point root 2. And the x value here and the x value here are called the roots of the quadratic function, or they are called the roots of the quadratic equation. Something we're going to deal with tomorrow in the next class. Next class, we're going to focus on calculating the coordinates of these points, the roots values. X values are those 2 points where the graph intersects the x-axis. They are called the roots. That was the question. Always stay. Everybody good?
Yes, sir.
Yes, sir.
All right,
Yes, sir.
All right. So if you never do it so good in the class and you're not so certain about certain things, when I post the video and send the video in the group, I want you to do the question over again until you can just work it straight without stopping and thinking. That is the level to which you want to always do your mathematics. You want to reach a level where you can do a question and you don't have to stop and think. You don't have to look back at anything. You just work the question straight. You understand everything that they want. It's just a matter of making sure that you are accurate in working out what you're working out. But you must understand it and know it to a point where you can do the question from beginning to end without having to stop and think. You should get to that level. The way to get to that level is to practice, 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 and practice again. So I want to, anybody who did this question, I have to be stopping and thinking and looking back and checking this and checking that. No. Do it out of your head again, straight. If I do it 5 times, good. All right. Let us not waste any more time. Let us jump and let's look at a few example past papers now so that you can see that, you know, this is the level of work that you are required to do. Let me find one of the more recent papers. I wanted to go through and find a question before class started, but I'm at work and I didn't get a chance to do it. So I'm just gonna have to search for questions. So let me bring up a past papers. Let me bring up past papers, CSEC past papers. And we're gonna do and look at one of the most recent one. Let's look at June paper 2. Let's look at one of the more recent papers to see if we can find a quadratics question. All right, let's see. 16, not in ascending order. This is May 2023, paper 2, part 1. Wow, all right, so 2023, the paper just done the other day. Let's see if there's any quadratics on it. I don't remember, so let's bear with me, right? This is how I got a copy of it. I don't get a clean copy of it yet. And this was actually section 2. So that is the end of it. So you won't find one there. So let me look at part 1 and see if there's any quadratics. And I'm talking about the section 2 quadratics. We have to complete the square and stuff. And so let me just go down to section 2. I didn't get a chance to sort of prep and look at which question we're going to do before. All right, but let's just see. Usually in section 2, the quadratics that were on now in section 2. This is the paper that was leaked. This is a quadratics question, guys. This is a quadratics question, right? But I think they wanted to just put in a graph, so they give us a graph. So I'm not gonna do this one now. I really want ones where we have to complete the square. And so still coordinates at the maximum and minimum point. It's gonna have a maximum as the square term is negative. But I don't want to do this one because this one is drawing a graph. I just want us to do where we're completing a square. Say they want us to do the axis of symmetry. And find the solution for this where the graph intersects the x-axis. And so I don't want to do this one because this one not really testing what we're on. We maybe do this one next week. Or do the other part about getting the roots, right? So this was a June paper this year that was leaked. That takes it in bother tomorrow. Let's look at 2022. Which is some here. Let's step and see. I want one where they're asking us to complete the square. All right, so we stay consistent with what we're doing in the class now. All right, let's see. There's any on this one. No, it's a linear programming. A topic that we're gonna be doing later on. All right, so there's none on this one. We can't set everything on every paper, right? Let's know that. But we have to learn everything. And let's look at 2021 then. 2021. All right, so this is something normally I would have done before the class and prepare, but you know, I came with the intention to do it, but I got tied up doing some other stuff. Let me see. But it's still there? Jump.
Yes, sir.
Yes, sir.
Just to the screen, all right? All right, I just asked him because I don't know what happened now. All right. So all these questions and all these parts, we're gonna do every single one of them. You know? I'm telling you from now. We're gonna do every single questions and all these past papers you see I've putting up here. Just a matter of when. Right? We're gonna be doing every single one of them. Right? There's another quadratics, but this time again I want us to draw the graph, right? So ask about axis of symmetry again. This one asking about axis of symmetry, asking about maximum minimum. But because I don't want us to plot the points, I don't want to get into the plotting of the point. You know, this one they gave us all the points, you know. So I really want us to focus on completing the square. So I don't want to do this one either. We'll do this one maybe next week. I want us to do one where we have to complete the square. All right. But I said quadratics, but remember then quadratics, we have other things to do in quadratics, right? So all these things we're gonna eventually do them. So don't think that we're not gonna do these things. 2021, there's no exam in 2020. Let's look at 2019. What they asked in 2019. Let's look what they asked in 2019. So all those questions I'm skipping over, we're eventually gonna do them, right? I just want us to look at one where they ask us to complete the square as well. 2019. That's functions. No, there's none on 2019 either. All right, 2018. Or maybe I forgot to some of the January ones. So we see some quadratics in there, but not what I'm focusing on yet. Right, so we do those other questions maybe next week. The one that I'm skipping over. I'm looking specifically for ones where we have to complete the square. Practice. Let's do a couple of them today. So that one either. Wow. I'll look at some January. Let's try 2017. I'm gonna look at January next. 2017. Let's see. Unless the marks it in section 1, 9, unless they're asking it in section 1. So I'll be either I'm gonna check January. Let's see if section because the syllabus would have changed. That's in section 1. This function is not gonna be here. I'm gonna check January. Is in January. Let's check January. I want one of the recent ones. January. All right, let's take a January recent paper. Maybe 2023 January. This is 2021, 2022. About 2023 here. All right. Let's go for 2022. This is January 2022. Section 2. See another functions here. I don't want us to plot points. Again, then ask us to write it in the form, right? I don't want this yet. I'll do that next time. I'm looking for one where we have to. They said quadratics a lot, you know, just that we don't finish the topic yet. Right? So we're gonna do these maybe next week. Right? So no, still no. I don't want that. I want to complete in the square one. This way to see how they set it when they set it. Mm-mm-mm-mm. 2021. This functions. This is still not one. Wow, so many of them are not. Maybe Maybe to change the frequency we wish to ask to complete the square, but still have to understand it. All right, let's try January 2020. 2020. Next time I prepared the thing before, so I'll have to be searching. I think I was to do it on arrival here, but got tied up in some stuff. I don't find one, maybe I have to just do one of the, again, this is not one. Aha, here's one. January 2020. Here's one, guys. Here is one. There you go. But I can see that. Here's one. Right. But I can see that.
Yes, sir.
All right, good. So this one is saying they give us this function. Clearly, that's gonna be a smile. Right? That's gonna be a smile because the A is positive, and the y-axis intercept is -2. Now we're gonna sketch a graph and everything, even if they don't ask us for that. But notice the first part, they want us to write it in this form. All right. So we're gonna, instead of using that again, we're gonna use A into x minus xt squared plus yt. It's the same thing, just that we know what xt means and what yt means, right? So if we're going to use that, we just need to calculate xt and yt. We can fast. Let's write it out from this standard form. Let's write the a, the b, and the c. The a is equal to 4, which is the number in front of the x squared there. The number in front of the x is -8, so the b is equal to -8, and the c is -2. C is -2. We're just going to calculate the xt and yt straight, right? So the xt is minus b over 2a, which becomes minus, that's this minus, then the b itself is a -8. So it's minus a -8. I divide that by 2 times a, and the a is 4. That becomes a positive 8 over 8, which is equal to 1. And now is a good time to show you another way to find yt. You see, when your xt come out to be a whole number like this, you can actually find yt by plugging the xt value in here. Remember, you know, yt is the y value on the function when x value is xt, you know. So you can actually, another way to find yt is to plug your xt value into the function. I'm going to do it both ways and show you that you're going to get the same answer. All right. So we can find it using the formula, which is yt equals 4ac minus b squared divided by 4a, which will be 4 times a, and the a is 4, times c, and the c is -2, minus the b squared. So we're subtracting -8 squared, so that's -8 squared, all divided by 4 times a, and the a is 4. I just need to simplify that down. All those big numbers, I prefer to just drop it in the calculator. So let me show you, because this is an exam where you use a calculator, right? So I'm going to use a calculator here and just simplify it. We're doing a math like exam, so makes sense. Use up the power of your calculator. So I'm going to drop that in the calculator. I'm going to send you the kind of calculator that I want you all to get for this class or for the subject. It's one of those textbook, we call it textbook display calculators. One way you can put in information exactly as it is on the screen. So you see, I'm able to put it in exactly as it is, minus -8, and I can square it, and it will come out and look exactly as I have it on paper. So we call it textbook display calculator. So it comes out to be -6, and size -6. So instead of waste time trying to simplify it down, put it in the calculator, write this exactly as it appears, put it in the calculator exactly as it appears here. Put it in the calculator exactly as it appears there. All right, so it's -6. But let me show you the other way now that you can find it. All right, I get the same thing. -6, I answer. Or let's use or in a different color. Let's use blue for the or method. Or because xt is 1, we can plug the 1 in there to find yt. So now you learn another method in this class. So we can say yt is equal to 4 times 1. 4 times 1 squared minus 8 times 1 minus 2. Now this 1 squared is 1. So 4 times 1 is going to be 4 still. This 8 times 1 is 8. So we're going to be subtracting 8 still and then subtracting 2. So this is really -10. So like 4 minus 10, see, you get the same -6. Same -6. So now you know another way that you can find yt. You can find yt by plugging the xt value into the function. That's another way to find yt. But understand that? But understand that?
Yes, sir.
So sorry, you would have
Yes, sir.
just, so all you do is put the same value you get for xt as the
Let's put
function
it in,
thing.
let's put it in the function. Because remember, you know, the yt value is the y value when x equals the xt value. Remember, xt and yt is at the same point, you know. So if you know xt, you can put xt in the function and let the function work out the yt value for you. It's just that normally when xt come out to be a fraction, we don't bother put the fraction in the function to work it out because you know it's a little bit longer. We just use the formula that time. So anytime xt come out to be a fraction, use a formula. Anytime xt come out to be a nice, easy whole number like that, put it in the function. So you can use the function to find yt as well as you can use the formula to find yt. Generally speaking, if xt is a fraction value, we use the formula to find the yt. If xt is a whole number value as it is now, it might be easier to just use the function to work it out. Understand what I've said? Understand what I've said, students?
Yes,
Yes,
sir.
sir.
Yes, sir.
So you know a second way to find yt. Very good. So if you never learn anything today, you learn that. All right. So the yt is -6. So know that the xt is that and the yt is that. We can write the function. Right? We can write the function. Let's write it in purple. This function, in the form that they want it in this form that we have in red, becomes f of x equals the a is 4. The a is 4 bracket x minus the xt is negative. No, sorry, the xt is 1. So put -1 square and the yt is -6. -6. Done. That's it. See that? So we could have done, for this question, we could have done just this and this in red and then write this answer. Right? This was not necessary. This part was not necessary. All right, we could have done those two and write the answer. All right. All right, so that is that. Next part now says state the minimum value. Just state it. What is the minimum value? We just need to state it. What is it? What is the minimum value of f of x? Somebody tell me. Unmute your mic and tell me the minimum value of f of x. We're talking this all class. Come on. So
-6, sir.
yes, the yt value, the lowest y value on the graph. Remember the f of x is y, you know? And you want the lowest value of y. The lowest value, the minimum value of y is yt. The lowest point on the graph where the y value is there, the lowest point. So it's yt. So state the minimum value, just write -6, that is the answer. If you want to write yt, which is -6, the minimum value is yt, which is -6. The yt value is the minimum value. Next part. Determine the equation of axis of symmetry. The axis of symmetry. The equation of axis of symmetry is what? The equation of axis of symmetry is what? Somebody tell me.
X equals 1.
X equals the xt value, which is x equals 1. That is the answer right there. Easy. All right, that is it. I think it's done. That's it. Exam paper. 5 marks for that. 3, 1, and 1. All right, 5 marks. I'm not going to do the sketch. Let's just see if we can find another one. Let's look at January 2019. Let's look at January 2019. See if there's another one. Let's look at January 2019. That is 2021. No, that is 2020. 2019. Let's just see. So moving on to finding the roots tomorrow, guys. The roots. Let's see what is on this one. Let's see if there's another one on this. January 2019. See, they like to give quadratics, guys. Not only to complete the square. This one, they wanted to plot it. See? They wanted to draw the graph. And then after you draw the graph, so they give you the graph to draw it on. And then after you draw the graph, I want to get the coordinates of the maximum point and the range of values of f of x greater than 0. So this is what we don't do yet. And then the gradient. These are stuff we don't do yet. But this is one that wanted to draw the graph, plot points and draw the graph. So we're not going to do this yet, because we don't really do this in class yet. All right, but eventually we're going to do it. But let's look at 2019. So you see they set questions on quadratics all the time. Let's look at 2018. We're just looking for the completing the square parts for now. Right. Next class we'll do those other stuff. 2019. But you see, those other questions will become easy for you, because you already know some stuff about the quadratic function. So it's not going to be difficult. 2019, 2018. This is an equation to solve. This is not one either. 2017. So we see that there are quadratics questions there, guys. There's quadratics questions there, but just that some of the stuff we don't do yet. This is just our first Saturday. So maybe next week, no, some of these questions we're skipping over, we will do. But I don't like to do questions if I don't teach the content yet. All right, I don't want to do questions that I don't teach yet. Maybe see if we can find one more and then we'll call it a day. Because the main thing was just to recap using the question, the classwork, do the sketch, and then here's one again. It's a quadratic again, guys. This question, another quadratic function. Let's say quadratics a lot. It's a quadratic function again. That's a smile shape. Use a graph to solve this equation. Again, we're not going to do this if I don't teach that yet. It says write down the coordinates of the minimum point. So this we can do, because we can see the minimum point right here. Right there. You can see it, right? I just want us to write it down. So this point, if you look at it, is 3 is the x value. This will be -1. This is -2, you know. So right here will be -1. So this point is going to be 3, -1. That point is 3, -1. So the answer for this is 3, -1. Easy as that. All right. Here now they're telling us to write it in a form. Write it in a form. Write this in this form. Now you tell me now, guys. Since I have the graph and I know the minimum point is 3, -1. Do I have to go through the process of completing the square from this to this? Do I have to do it? Do I need to do it? Do I need to calculate the xt using xt equal minus b over 2a and stuff? Do I need to do all of that? I know the minimum point is 3, -1 right here. I see it on the graph. I have the graph. This time I'm working backwards. I have the graph. I can see the graph. The minimum point is 3, -1. Do I need to go to the process of doing this computing of the square using the formulas and stuff, the formulae and stuff? Do I need to do that? Somebody tell me. I don't need to do it. Why don't I need to do it? Because I know the minimum point is xt yt equals 3, -1. So I already know that xt is 3 and yt is -1. And the process of computing the square is about finding xt and yt. So I don't need to waste time and work them out again. When I take this and I write it using our method, which is to say it becomes a into x minus xt squared plus yt. I have the graph. I can see that xt is 3 and I can see that yt is -1. And from this expression, the a is clearly equal to 1. See, the a is 1, you know. From this expression, the a is equal to 1. So I know the a is 1, I know xt is 3, and I know yt is -1. So I don't have to calculate it out, calculate it down. You can just write it as this, see there? This becomes 1 bracket x minus 3 squared, and this is yt minus 1. So I'm going for the plus yt, I'm going to write -1. And I'm done. This is it. This is the answer. I do have to calculate it because I know xt and yt because it showed me the graph. So I know xt and yt from the graph. I do have to calculate it. But I'm going to calculate it this time just to show you that I'm going to get the same values. So let me move this over, and I'm going to calculate it and show you that the values will be the same when I'm done. If I use back the method that we learned. Let's do it in purple right here. Let's do it right here. All right, so from this standard form, from this standard form, I'm write out the values. From this standard form right here, the a is 1, the b is -6, and the c is 8. And I'm telling you from the graph that xt is 3 and yt is -1. I don't have to calculate them because it showed me the graph. Well, let's calculate them and show and prove it to you. Let's calculate them. Just to prove it to you. So xt is minus b over 2a. So it becomes equal to minus, that's this minus. This b is a -6. So it's minus a -6 over 2 times a. The a is 1. So it becomes 2 times 1. 2 times 1. This minus becomes a +6. It becomes a +6 over 2. See there? It works out to be 3. Same 3 that is at the turning point, xt. So you know from the graph, you don't have to work it out. And if I use a formula way to do it, now that I know that this is 3 now, I can take this 3 and plug it in the formula here and there now. I work out yt now. But let's say I'm using the formula. It's just to prove something to you. Yt using the formula is 4ac minus b squared divided by 4a, which will be equal to 4 times a, the a is 1, times c, the c is 8, minus the b is -6, so squaring the -6 squared all over 4 times a, the a is 1. If you work this down, yt, this is going to become 68, 48. It's going to become 48. No, 4 8 32, sorry. 4 times 1 is 4. 4 times 8 is 32. 8 4 is 32. That's 32. minus, you're gonna be subtracting a 36. This minus is this one, and then this negative 6 squared is 36. 36 divided by 4. 4 times 1 is 4. 32 minus 36 is negative 4. Negative 4. Negative 4 divided by 4. That is negative 1. Same negative 1 that you have on the point. You understand that, guys? So if they give you the graph and you can see where the point is, then this x value is your xt. And this y value is your yt. All you have to do is drop them in the form a into x minus xt squared plus yt. You know xt and yt, you know the a is 1, becomes 1 bracket x minus the xt is 3 right here, squared, and the yt is negative 1, minus 1. So you don't have to work minus 1. You don't have to work them out again because you have it from the graph. But understand that?
Yes, sir.
Yes, sir.
Good, good.
Yes, sir.
All right, so we're learning. Progress before perfection. Lower yourself. This one says, all right, so we're not doing that. And we're not doing this. All right. We're not doing these parts. Let's look at 2016. What does want to? What time is it now? Start at 11. Let's see if we can rough another half an hour and get 2 hours out of it. All right. Let's see if we can find a couple more questions that we can learn something from. More maths equals better maths every time. So we'll learn something from that one. So 2 things we learned today that we didn't do in class, that you can find yt using the xt value in the function, and that if you see the minimum point on the graph and they give the graph and you can see the minimum point, then you know xt and yt from the graph, and you don't have to calculate them over again. They are there on the graph. Just plug them in the formula. Plug them in the form x minus xt plus yt to get the vertex form. If they show you the graph and you can clearly see the values. All right. So let us continue. 2016. Let's see if there's any on this one. More maths equals better maths. The more practice, the better we'll get at this thing. And the more stuff we'll learn and understand. All right. So let's go find another one. Just like the other one. All right. So this don't have any. Let me see if there's a quadratic. No. No, this don't have any quadratics on it. But not on this section. Nope. Let's look at 2015. Now go back to the June and work our way back down. I think we had stopped at June 26. But let's look at 2015. 2015. January. January 2015. You see, occasionally comes in section 1, right? But I'm mainly looking for them in section 2. Right here. So functions. There you go. There's one. Find one. 2015. There's one. I say most of they give smile as well. When they give a graph, sometimes they give the frown, right? But most of they give smile. Most times that's smile. So there's another one, guys. They want us to write this in this form. In other words, they want us to complete the square. And I say most times again, they put A, H, and K. Most times with a plus. But because they change it occasionally, we don't want to take the chance. So we're going to use our xt and yt again. And we know what xt and yt stands for. So instead of using this, write it. Instead of using this format, we are going to use, which is basically the same thing, right? We're going to use a into x minus xt squared plus yt, the same format, right? Our method, xt means the x value at the turning point, yt means the y value at the turning point, right? So we're looking for the turning point in our method. So we're gonna go and say xt equals minus b over 2a. What is the a? We get the a and the b and the c from this. Let's write them out. The a is equal to 3. The b is equal to a positive 6 this time. See, there are positive 6. And the c is equal to negative 2. The c is this negative 2. I can actually make these markings on the exam paper now, guys. You can make these markings on the exam paper. It's okay, right? Because a human being marking the paper, you can. But generally speaking, you try not to write outside of these marks. So this C, if I'm doing an exam, I'm going to write it here. C equals negative 2. Try not to write outside of these marks. But that is where they're going to cut the paper to scan it. So try not to write outside of those marks. All right, but let's continue though. So now that we have the A, the B, and the C, we're just plugging in the values. And so we're gonna get minus, and then the B just 6 now. So just minus 6. There's no minus this time. Divided by 2A, and the A is 3. That is negative 6 over 6, which then becomes negative 1. So since this is a whole number negative 1, we can actually find YT by plugging it in there for the X. All right, I'm going to do it both ways. So let's do it that way now. So I want to say YT will be equal to 3 times minus 1 squared plus 6 times minus 1 minus 2. That's if I use the method of plugging it back into the function to find YT. That's another way to find YT. If we work this out, this down, this is a positive 1, and the multiply by 3, you get 3. This becomes a negative 6. This becomes negative 2 still. So it's like 3 minus 8. 3 minus 8 is negative 5. This becomes negative 5. Let's do it the other way with the formula, just for practice, and just to show you that the answer is going to be the same. Or to check if the answer is the same. We can use YT equals 4AC minus B squared divided by 4A using the formula method, which would be equal to, let me shift this way. Well, let's work it. It should be equal to 4 times A, which is 3, times C, which is negative 2, minus 6 squared, because the B is 6, divided by 4 times A. 4 times 3, A is 3. So YT this time will be equal to, now 4 times 3 is 12, and 12 times 2 is 24, so that's a negative 24. And it's subtracting, this minus don't change, remember, it's subtracting 36. 36. And you're dividing that now by 12. By 12. So minus 24 and minus 36 are minus 60. Minus 60 that. So it becomes negative 60 over 12. 60 divided by 12 is 5. So that's negative 5. So my YT is negative 5. So I said this time kind of easier to just plug the negative 1 in there to work it out. So in this case, maybe I would prefer to do this one in this exam. Once I get a whole number here, I'm going to use this method rather than this, rather than the formula method. And now that I know the XT, the YT, now that I know the XT and the YT and the A, I can now write my vertex form. And so let me put it in red. So this expression that I want me to put it as a function. Let's write it like this. The function becomes f of x equals a, or we writing it like that, you know. It becomes a, which is 3 into x. I really is this we're writing this. This is what we're really writing this. A, which is 3 into x minus a negative 1, x minus a negative 1. Don't forget the square. So this minus is going to become a plus. And then plus YT is negative 5. I'm going to write minus 5 here. And then consolidate and write 3 into x. This minus becomes a plus 1 squared minus 5. That's my answer right there. nice and easy. So we did this part 2 ways. But generally, for the exam, I think this and this would be enough. Don't need this in the exam. All right. And then you write this expression. Next part now says, hence or otherwise, state the minimum value. See, state means that you don't have to calculate anything. Minimum value, remember, is the YT value. So you just have to state it. In the exam, you cannot do this, you cannot write -5, Negative marks. Just write -5 because it's stated. Just write -5 on the paper, right there, and get the 1 mark for it. All right, but you can say it is the YT value, which is -5. All right, something else. It says state the equation of axis of symmetry of the function. Axis of symmetry, remember, is x equal whatever the xt value is. What is xt? It is -1. So we answer i.e. it is x equals -1. That is the axis of symmetry. X equals -1. They don't want us to sketch. All right. So you know this one is asking us for a sketch. Sketch a graph showing the intercept with the y-axis and the minimum point. They want us to sketch it. Let's go. So remember now, let's just analyze it here. Because A is positive, it's going to have a smile shape. The minimum point is the XTYT that we just calculated, which is -1, -5. See them here? -1 and -5 will be the turning point. Let's put it there. -1, -5. Like I'm setting it up. And then the y-axis intercept is based on that point. So y-intercept. Let's just write it over here. Just for notes for ourselves. Y-intercept will be 0C, which is 0, -2. So it's gonna have a smile shape, called A positive, this minimum point, and that. I'm sketching it now. Let's sketch it in this space. Let's go for the black. So put in the y-axis and put in the x-axis. So we need a smile, guys. Let's get it in blue or purple. We need a smile that turns at this point, -1, -5. That's a negative x value and a negative y value. Negative x is this way, negative y is this way. So we must turn somewhere down here. And then after we turn somewhere down here, this point must be somewhere on this leg where the y value negative. So we need a smile, that turns down here and crosses somewhere down here where y value negative. All right, and then all we have to do is just draw it. Let's draw it in purple. Turn down here and cross down here. So we can draw it like that. And then we'll label the points. So this point is the minimum point, -1, -5. This is a y-axis intercept, 0, -2. And if we want to show the axis of symmetry, we can label the graph. F of x is f of x. No, y is a y graph. So it's a graph of y. Let's label it up properly. So maybe in the exam I'll write y equals 3x squared plus 6x minus 2 sketch. This is just a sketch of it, not accurate. And then I'm going to show the axis of symmetry since we spoke about it, right? In one of the questions here. Just for our purpose. A vertical line through here now is your axis of symmetry, which is x equals -1. The axis of symmetry is x equals -1. X equals the x value right here. That's it. So you see how they set the questions. Some questions ask for a graph, some don't ask for a graph, some ask for minimum point. They ask for various things. Some ask you to sketch it, some don't ask for sketch. Some ask for axis.
Sir, can you go back up to the first one? The first one.
Right here. Okay. Okay now?
Yes, sir. Thank you.
So this was just another way of finding white here in the box there. All right, what time is it? Let's find another one. More maths equals better maths every time. 2015. Let's look at 2014. Let's just look at January 2014. And then we can maybe look at some of the June ones again. June ones again. 2014. Let's see if there was any in 2014. Let's just look and see. 2014. All these questions that I did, I wanted to redo them, you know. I wanted to redo them. I wanted to look back at the video and I send it, and I wanted to work the questions over again. All right, so this is when the paper, you were not allowed to write on the paper. They gave you a booklet. All right, I think they started the paper thing about 2015. So this one now, they would give you a booklet. For your exam that you're doing, you write on the actual question paper and send in the paper with your work. Let's see if there's any here. It's a quadratic, you know. This question is a quadratic, but it has some stuff on it that we have not done as yet. But this one is asking us to calculate B and C. So this is a topic this is something that we're gonna do next week, not tomorrow, next week, which is finding the function having been given the roots. So this one, they give us the roots. So the roots here, -1 and 5. And because they gave us the root, and we also know the y-axis intercept, we are to determine what the function is up here, the B and the C. So we're gonna learn how to do this later on. Not yet. So this is a quadratic again, but it's something that we don't do yet. See, it's a quadratic function. We don't learn this yet, finding the function from the roots. All right, so let's go back to the June exams and see. And let's work from 2015 up. Let's go the other direction. June exams. Let's work from June 2015. Let's see if we see any more. We'll call it a day. It should take us up to 1 o'clock. 2 hours of practice. All right, let's see. 2015. Let's look in it by chance. I used to put it in section 1. I used to put in section 1 some long time ago, but in recent times, the more recent exams is section 2. See, look at this. It's a quadratic question, you know, in section 1. But this is back in the day. The more recent ones want to be in section 2. So they're not asking to complete the square. They don't want to draw a graph. This one they want to draw a graph. See, on graph paper, draw the graph. But it is a quadratic function. All right, let's say they're asking for the line of symmetry and the minimum value. See that? The minimum value. All right, but we don't want to do this. We want the one where you have to complete the square. So let me see, by chance, just by chance, they still ask it. I doubt they will ask that in section 1 and then ask again in section 2. Doubt it a lot. Yeah, they wouldn't do that. Let's look at 2016. So all those questions I'm skipping over, guys, don't worry. We will eventually do them. We're gonna do all of them. All these papers you're looking at the screen, they're all for you. By the time we get to May next year, in fact by March, we have gone through all of them. Somehow we've gone through all of them. All these papers you're gonna have to do. 2016. Did we look at this one already? I think we had gone down to here now, down to 2016. So I think we have exhausted the more recent papers. That has quadratic, and it would have to maybe go down like, you know, in some of the earlier years now to see. But I think I'm gonna stop it there then. I think I'm gonna stop it there. But I go to the thing, okay, today learn something, refreshed.
Yes, sir.
All right, good. So you're gonna do me a favor now and redo the question. So when I send the video, I'm gonna send a link to the video. I actually have the video online on YouTube. As really I putting it on YouTube is that I cannot have a limited space on the Zoom site to keep the classes. Right? Because it's not a teaching class really, it's just a revision class. I record it on YouTube, so I'm going to send you the YouTube link for you to watch the video. I can't put up this, I have a limited space on Zoom. My Zoom storage is limited, so I can't put too many stuff on it. But I don't have any limit on YouTube. All right, so I'm going to send the link to the YouTube, and you can just go and watch back this video. And as you watch back the video, you can go and watch it now actually, because they're live. Because they're live, it's available right away. So you can go and watch it. And I want you to redo the questions for me, please. Redo the questions right away. So when you're watching it, you pause the video, you try to do the question yourself, and you watch the video again. We need to master this thing because it will help us to do the stuff, other stuff that is coming up in quadratics. All right, guys. So please do it for me today so that tomorrow we're moving on to something new. We're not coming back to this only in revision. We're coming back to this. Okay, everybody?
Okay, sir.
All right. Have a great rest of day and do the work for me, please. And when you do them, you send it to me on WhatsApp, the practice that you do. Send them to me on WhatsApp, okay? Let me have a look at it and let me get the confidence that you're actually doing them. All right, bye everybody. I'm gonna send the link right away. All right,
sir.
all right, bye-bye.
Bye, sir.
Okay.
All right, bye, sir.
All right, bye-bye, bye-bye.